Here we have some algebraic expressions. This is called the linear expression. These are two linear expressions, but when we will multiply them, we'll get a quadratic expression. So you can say this will lead to a quadratic expression. Here we have three linear expressions. These two when multiplied will give you quadratic, and these three will give you the cubic one. So you can say this will lead to a cubic expression. Similarly, this will lead to a biquadratic expressions or polynomial. Okay, you very well know how to multiply these. When you multiply this, you'll get a quadratic expression, here cubic and here biquadratic. But today the video is not about how to multiply them. You are well aware of that. The video is about how to factorize the expression which we get after multiplication, means how to get back to these expressions when their answers are given. Okay, for example, here we have a question, we have to factorize them. It's a cubic one and it is therefore made up of some factors, and suppose they are made up of three linear factors because it's a cubic one. So we have to find out those three factors. Process of factorization has always been little bit trickier. Okay, and to find out the factors of this, we must closely look at the procedure of expanding them. Okay, see, when we'll multiply these two, we are going to get four terms. How come? This will multiply with 2 and this is going to multiply with again these two. So it's these two are going to multiply with these two. So we are going to get four terms which will combine up to give us 3. Means some of them will combine to give us 3. Here initially these two will give us 4, and those 4 terms are going to multiply with these two. So we are going to get 8, but then after addition or means there will be some clubbing up of terms. Okay, here we are going to have 8 with these 3 and then 2 16, and then further there is sub clubbing up. Okay, so the end product is entirely different, means it won't resemble this. But something we can tell about the answer by looking at these, that the first term of this expansion is gonna be x square and the last term is gonna be minus 2. When x goes to x square. When minus 1 goes to 2, it's minus 2. And the middle terms are when x goes to 2 and minus 1 goes to x. Those are going to be middle term which gets combined later. So in all of these expressions, we can predict the first term and the last term. Here the first term is going to be x cube, x into x into x, and the last term is going to be minus 3 into minus 2 into plus 1, which is going to be plus 6. Here the first term is going to be x raised to power 4, and the last term is going to be 5 2s are 10, 3 2s are 6, and therefore positive 60. Okay, so this is what we get to know about their answer by just looking at the term. The rest procedure is very long, so there are many terms in between, and which is a result of clubbing up of some other terms. But there is only one term which is x raised to power 4, and it's only one constant term which is 60. So this observation can be quite useful to find out the factors of this cubic expression. Okay, so by looking at this, we can tell that this is made up of, the linear factors here are made up of x, x, x. Okay, and here the constant term is gonna be such that the product of these three come out to be 2. So what all three terms going to give you the answer as 2? So those are gonna be 1, 1, 2, where all are positive, or it could be minus 1, and 2, or it could be 1, 1, this one. Okay, so this is gonna give us positive 2, this is gonna give us positive 2, and this is gonna give us positive 2. So now we got to know by using this simple observation, we can actually factorize this. We got to know that the term here is gonna be either these three or these three or these three. Okay, so now comes the procedure of checking, how to check which of the combination would be here. These are the possible factors, or this or this. Okay, so if these are the factors, so this side will become 0 if we put x equals -1 or if we put x equals to -2. Okay, so if this term becomes 0 on putting -1, that means x plus 1 is the confirmed factor. And if this becomes 0 with x equals -2, then again this full is the confirmed factors of this. Okay, so if these are the factors, then -1 and -2 should be the 0 of this expression. Okay, so if you have to check whether these are the factors, you simply have to put -1 this. If it turns out to be 0, that means x plus 1 is a factor. But if x plus 1 is a factor, then the possible factors are this or this. Then you have to substitute -2 also. If then also it turns out to be 0, that means this is the confirmed factors. Okay, otherwise you have to go for the other options. Here these three become 0 if instead of x we will put positive 1, or if instead of x we'll put -2 here, -2 here, and -2 here. And as this turn out to be 0, it will make all of them 0. And here the possible zeros for this all of them is -1, +1, and +2. Okay, now this thing is confirmed that this expression is going to become 0 with either of these values. So these are the possible zeros. These are called possible zeros. Okay, possible zeros. Okay, so once you'll confirm the zeros, any of them, okay, then you can lead to, that will tell you about the factors of this. No, so you may start checking now. So it's up to you from which number you wanna check. Okay, we can start checking with -1. Let's substitute -1 here. So I have checked it here. It turning out to be 0 when I substituted x equals to -1. That means x plus 1 is the confirmed factor. Now, when you substitute the value, you have to be little careful. There are 4 terms, 1, 2, 3, 4. So you must get 4 answers. Okay, so do not start operating the terms in between unless each one of them is sorted. You should get a 1 value for this, then 1 for this, and then 1 for this, and then 1 for this. All 4 of them separately, then operate them with one another. One thing is this. Second thing, be careful when you are substituting a negative value. So here it was -x and x was -1. So minus and the value of x is -1. So the students do make mistake at this point. Okay, anyways, this is the confirmed factor. So the confirmed factorization for this is either this or this. Okay, now it's up to you. What do you want to confirm? You want to go for substituting -2, or you want to go for substituting +1. Okay, substituting +1 is always easy than substituting -2 here. No, calculations are easy. So you may choose for substituting +1. Okay, if x minus 1 turns out to be a factor, then this is gonna be the factorization. No, this is a star logic here. If this turns out to be a factor, then this is the factorization. If this does not turn out to be a factor, then for sure the factorization is this only. No, so let's check. Here I have checked. I have substituted x as 1 and it turned out to be 0. So 1 is the 0 of this. That means x minus 1 is the factor. No? One more thing. If 1 turns out to be 0 of this, then x minus 1 is the factor. If -1 turns out to be the 0, that means x plus 1 is the confirmed factor. No, now x plus 1 and x minus 1, surely they are the factor, x plus 1 and x minus 1. That means this is the factorization for the given thing. No, so from here you can mark this conclusion as 1 and mark this conclusion as 2. Now you can say that 1 and 2 together implies that x cube minus 2x square minus x plus 2 is equals to x plus 1, because this is what you have been asked for. You have been asked to factorize this. So what did we do? We just focused on the constant term, and we got to know these are the possible terms which could be here. If these are the possible terms, so these are the possible factors, and if these are the possible factors, then these are the possible zeros. No, so these are possible constant terms of factors. And what are these? These are the possible factors, and these are possible zeros. And by checking these, whether these are the zeros of this also, we can confirm the factors, and that's how the factorization is done.